Hey guys, Bukula here. Hey, we had another CME, guys. It makes three of them. I'm going to show you guys some interesting stuff here, but um, I got you back here on the 11th over at the Core 2 from Stereo A. So the Earth would be over here, Stereo A's here looking at the sun. So anything that blows off that way would be Earth facing possibly, unless it gets shot way down here, up here, what have you. But normally if it's coming off this direction, we're at least going to catch a glancing blow. Now, some of the predictive models are actually showing these, at least the first two, on their models, and I'll take you over there and see that in just a second. But this is back on the 11th, and we'll just push play, and you'll definitely be able to see it. I mean, it's not like it's hard to see. Okay, there's the first one. We'll go the next day. Okay, this is the 12th. There went the second one. I'll slow it down so you guys can see it. Okay, there's a little bit of skipping time there because this is what it did. It missed a couple hours, I think, there. Maybe, let's see what it does. Well, no, it just flipped to the next day. But that's number 2 right there. That was on the 12th. So now we got one from the 11th and the 12th. Okay, now we're here on the 13th. That first one you've seen was just the end of the second one. Okay. Let's back it up a little bit and I'll tell you what I mean. That right there was the result of the previous CME. So that's the same CME. That's number 2 CME right there. Okay. Now, when I push start here, we'll see the, oops, reversed, didn't it? Okay, there's the third one right there. First, the second one. Okay. Then we got third one. All right. Now, what I found interesting is on this last one, if you look close over here, guys, you can see that it reacted over here too, almost 180 degrees. All right. Now, we see that pretty often when we get CME, solar flares, what have you. Seems like the 180 degrees out, the sun has a reaction also. I think it's kind of like an exhaust effect, I think. I'm not really for sure on that. But I think they're related. You know, when you get these bigger ones, I think the sun just reacts over here too. And I'm going to show you here on SDO here. Okay. Okay, let's go. Let's close that out. Now let's go to over here to these links at planetxnews.org. Scott's page over here. He's got all these links, and I've shown these multiple times. But what we're going to do is, if you guys ever get over here and you go to Stereo Core 2, I'm going to show you how to get to some pretty decent videos here, okay? Time-lapse videos, anyway. You go there, then you go over here to the latest image. Okay? And then you're going to get this. You're going to get all these images, right? Now, that's just one single image that's going to show you on these thumbnails. Now, do you see right here where it says SDO, SOHO, and MILSA? Excuse me. We're going to go to SDO because that's the view from the Earth. Okay? The satellite's out in front of the Earth looking at the sun. So you click that, and then you go to AIA HMI Browse Data. Right there. Okay? Then if you scroll down, you can pick your angstrom. See where it says telescopes right here? And your angstrom will be here. And it even gives you the color, which is cool. Because just for laymen, it's really cool to have that there because you can see what color it's going to actually be before you click on it. Now, what you'll have to do here is you click on whatever angstrom you want. And what I'm going to do is I'm going to change it to, let's just do let's do the purple one. How about that? 211 purple, okay? Angstrom 211, angstrom, which is the purple one. Then you click over here at the top, it says dates. Okay, that comes up. And that's the beginning date. So you'll want to click on 13 there because you won't be able to see nothing just from the 14th. So you can click your time here. I'm just going to go roughly to where it started. It wasn't And then you can go there, and you click that. So then it gives you, or you can just simply type in the date also. But I find using these calendars pretty useful. Then the second bar here, drop down bar, is the end date. Okay, so, you know, always go to the latest one it'll let you. That way you catch all that you can. And then you just scroll down a little bit. You can set your resolution if you want. I'm going to hit submit, and then this is what it gives us. Okay. If I can... Oops. Sorry about that. What the heck did I do there? Huh. If that does that to you, you got to click back on these bars, and then what you just clicked before will be right there, and you just click on it. Okay. See it right there? Okay, let's just... There it is. Okay. And then we'll hit submit again. Alright. So this is what we got. Let's scroll up here. See that blow off right there? And what I find interesting, watch the hole it leaves. Look at that. I mean, it opened up a corona hole. Now it looks like it's going to close back. But that was, yeah, it's pretty sizable. I mean, I ain't saying it's a huge CME because I don't know that it is that big. But I do think it's earth facing. You know, I do think we'll catch another blow from this one. So watch right in there. Watch this. Boom. And it is caught this sunspot right here is causing all of it. Well, it's giving the energy to cause this. Okay. Now, if you look down here, you can't really see it very good on this angstrom, but you'll see that something reacts at the same time as it does up here. Okay. If you watch real close, it's kind of hard to catch on that one. Okay. So what we'll do is we'll back up and we'll go to the 304. 304, you're not going to get, what you get is more of a contrasted view. What I mean by that, you get better definition, but you don't get the broader spectrum, is what I'm trying to say, if that makes any sense to anybody. You're not going to have any like haze or anything. So what we'll do is we click, I think it's 304, 305, yeah, 304 angstrom. It's the red one. You hit done. And then again, if you just hit these timestamp bars, once you enter the first one, you can just click that, and the same date will pop back up. Okay, so you're looking at the same time frame as previous. Okay, now this is where it gets kind of interesting. Okay, because at least I find this very interesting. All right, now you're going to see it here. Okay, you see that? Now watch it again. Boom, right there. Okay, but watch down here at the exact same time. Boom. It reacted down there too. I mean, at the exact same time. So, you know, whatever is causing this is, you know, that energy is able to affect the sun in such a way it's blowing off in two spots at once. Whether these things are actually connected magnetically, I don't know. I would almost think that they would have to be for them to blow off at the exact same time. I could be wrong on that, but I just found that really interesting that that's what that was. Okay, now if you want to slow this down, all you got to do is hit the minus button a couple times, and that's what we'll do here so you guys can get a better look. Okay, again, we're looking here and up here. And again, that's sunspot 2741. That's that second one. Okay. Now, these sunspots have been active for a good amount of time, guys. Okay. 2740, which actually looked like it was going to completely go away, and it didn't. Okay. It's over here right now. It's actually starting to get a little bit more energized. At least from the other angstroms, you can kind of see it. So I'll zoom in right here so you can get a good view of this. At least one time here so you guys can. Okay, here it comes. See that? And then, yeah. I mean, it's, you know, I don't know, man. I mean, it's definitely from that sunspot. And again, if you look down here on the bottom left, you're going to see it react there too. Okay. So with that being a filament release, it probably let some plasma and stuff go. So that would make it a CME. It wasn't just a flash of light or radiation like a flare, like an X flare. Now, so with that being said, that makes 3 of them, right? Earth facing. Let's back out of this. I'll take you back over to these links. Okay, over planetxnews.org. What we'll do is if you guys go down and you go to space weather, okay, you will get, you know, solar wind speed, all these kinds of different information all in one spot, and I've shown this before. Now look at this. 24-hour observed maximum. Okay, that's a G2. Wow, that just popped up, guys. That's something that wasn't there a minute ago. We are having a geomagnetic storm right now that we haven't had one this big in a while. I'm just seeing this for the first time. This is a G2. The highest I've seen in a while has been a 5. So yeah, man. Maybe it was that CME finally got here from back on the, I think it was the 10th there was one. There was one there on the 11th too, I think. But usually it takes 3 to 4 days before they get here. So I'd about bet that's what that is. So, yeah, I'm kind of surprised to see that. I didn't really expect to see that. So it makes sense why the magnetosphere tools have been going a little crazy. But this X-ray solar imager is pretty cool too. We'll go ahead and take a look at its time lapse because it's just neat to look at. I think anyway. Sometimes it takes a minute to load, and other times it loads lightning fast, like that time. So just watch this, and you'll see it. There it went, boom. See that? So yeah, that's the third one. That is not why we're having a geomagnetic storm right now, okay, guys? It's going to take a minute for that to get here. It's going to take days. So, but the ones previous, and if we go back in time, you can go back as far as the 10th. I think we had some on the 9th. It was about every day there for a while we were having flares and CMEs, and it was all because of this active area. Okay, this is 2740. It was actually 2738, I think, the first time it made it around the sun. This thing actually went around the backside of the sun, survived all the way back through again. It's making its second trip, guys. Okay, they renamed it. I don't know what the qualifications for having to rename something, but yeah. Something else that you're going to notice here, you're going to see this get staticky right here close to the end. And what that is that's that energy. It's picking it up. Okay? Particles. Anyway, we'll go down here, and this is really what I wanted to show you because this is the Enlil tool, and what this is showing, if you look up here, it says plasma density, and this is basically solar wind speed. They call it radial velocity there, but it's basically the solar wind speed. Okay. Now what I find interesting, normally when the plasma density goes up, the solar wind speed goes down. And it did, but you don't see these big spikes down here. Now maybe that's normal. You do see a small spike like that, but you know, I don't know. But what this tool is, so you can, if you look at the date, it says 5/18. Okay, that means this is predictive. It's a predictive tool. This stuff hasn't happened yet. Now, if you look at the date here, 12. Okay, so when I start this time lapse, you're going to see this yellow line over here start over here and just roll across, and that's the time it's trying to show you. Alright, now the green line is conditions at the Earth. Okay, this green line. The red line is stereo A. So that's conditions of where that satellite's at. That's why it's giving you different ones here. But what we want to pay attention to is right here, right now, the Earth. Okay, and this spiral graph really shows it well too. You'll see it once I start the time lapse. But if you're looking at these spiral graphs, excuse me, I believe that's the Earth. Okay, that's where it's at. All right. So I'm going to start this time lapse, and I think you guys are going to find this kind of interesting. Again, I usually watch the yellow line first because I think it gives you a better idea when stuff's going to get here. Now see, this is where we're at right now. See, I should have paused it, but watch this. Okay. Now what you're going to see where these things peaked, if you were watching over here on the spiral graph, you'll see these bows coming at the Earth. Okay? When that hits the Earth right there is at one of these peaks. See that? And then there's one right behind it. That's two CMEs Earth facing. Okay, right there. Now they're going to have to add a third because there's another one. So, you know, that is what it is, guys. I mean, we can't really... There's not a whole lot we can do about this stuff, but yeah. I mean, is this going to be, oh my gosh, oh my gosh? No, I don't think it is, guys. But 3 of them in a row like this, Earth facing, and our magnetic field's getting weaker. You know, if these things were huge and this happened, and just the fact of multiple ones, you gotta think that our magnetosphere takes a second to recover. So when we're getting these back-to-back blows, the second one becomes a little bit more powerful than it initially would have been if it was by itself. Okay, so keep in mind that this model is, you know, if we come back and look at this tomorrow, I would almost bet you that there'll be a third one back here. Okay, and then there'll be another spike out here somewhere. So, yeah. But, yeah. Anyway, I wanted to show you that. Now, see, look, this is showing it too. It's a G2 solar storm, okay? Geomagnetic storm. I don't think we've had a G2 here for a few. Now, look at this. You guys see this right here? This is the auroras. Alright? That's right now. So, if you're living in Canada, in this area right here, you're getting a show, guys. I would really try to go outside and check that out. That's an intense signature for aurora. That means that's a lot of energy getting bounced off by our atmosphere. Okay? So, you know, when we get geomagnetic storms, the auroras always increase. And that's why. And if you zoom in enough here, you can kind of see that, you know, Maine's getting in on a little bit of this action, and it's even creeping down into the Montanas right here. Montana, and then, you know, North and South Dakota. North Dakota mainly there. You got Minnesota, the northern part of the United States. Okay? So, yeah. I mean, that's a cool part of it, but, yeah, we got to really pay attention. A G2 isn't... I mean, we could have satellite disruptions, cell disruptions. I don't think we're going to see any power grid stuff. Honestly, if we were, it would have already happened probably because this is showing up now. So it's already hit the Earth wherever it's going to hit. Now I think I would be paying attention to earthquakes. Okay? When we see this stuff, let's just pay attention to earthquakes because that's really important here. But yeah, guys, I mean, 3 of them. I haven't seen that in a very, very long time. Okay? Now, this geomagnetic storm, guys, if it gets up in here into the 7s, 8s, okay, that's when we can start seeing some pretty good activity. You know, as far as physically seeing power outages and stuff like that. Definitely, if it gets to a 9, we'd probably see something here. But we should probably really pay attention to, you know, like earthquakes and stuff here very shortly. Okay, I'd be very surprised if one doesn't pop off pretty big here in just a few minutes, next few hours anyway. I would think. I could be wrong. You know, I don't really predict any kind of earthquakes and stuff, but I have been learning quite a bit about that, and I do know that solar energy causes a lot of our earthquakes. The magnetic connectivity does from us to the sun. So, but yeah, I just wanted to bring that to you guys. And you know, it is what it is. Now, I guess what I could do here is I'm going to show you guys this. Okay, this is our magnetosphere, and this is what happens when we have these geomagnetic storms. See that? This is the velocity one. So watch this. I mean, this is intense. Okay? I mean, that's very intense stuff, guys. All right. Now, what I'll do here is I'm going to go down to seeing all that. I mean, that is just intense. When you start seeing all that happening all at once, I mean, man. So, we'll go down here and we're going to look at the pressure. Oh, my good gracious. Look at this. Wow. Yeah, I'm sorry I'm laughing. It just really, when I see stuff like this is crazy. Yeah. Man, I'm going to hit play. Sorry about that. Is it not going to let me play it? Huh. It's not giving me a time lapse. Wow. It is there, but it's not letting me see the pressure time lapse. I wonder why. Huh. Wonder what's going on with that. But yeah, this is the density. So, yeah, you're going to see this get a little crazed out too. I mean, when one of them gets crazed out, they all do. I mean, look at that. I can tell you right now, I've never seen that happen. Now, we are, like I said, we're having a geomagnetic storm, obviously. So I would point to that for the cause of this. But, yeah, you know, it is what it is. Let's see if it'll... Nothing. Wow. I'm going to back out of that and go back in there and see if it'll let me do it. Okay. Let's see if we can't get that to work for you guys here real quick. But look at that signature, guys. Man. Alright, cool. There it goes. It's going to do it. Now, what I want you to pay attention, this is the Earth. Watch this red creep into our area right to the surface. It's going to make it to the surface there. At least into our atmosphere there, the pressure part of it. So, yeah, guys, I definitely would be paying attention to earthquakes right now. I mean, look at this. I mean, that's crazy. Wow. Anyway, guys, God bless. Yeshua saves, and I'll try to keep you guys updated. You can drink this Kool-Aid.